Hi friends, welcome back to my channel. Today we are discussing classical mechanics previous year question paper. The degree of freedom of rigid body fixed at one point is equal to 3. If they ask the question, the degree of freedom of a rigid body moving in three-dimensional space, then the degree of freedom is 6. If the degree of freedom of a rigid body rotating around a fixed axis, then the degree of freedom is 1. A particle of unit mass is attracted by gravitational inverse correlation of force to a fixed point. The Lagrangian function of the system is. Here they are given for option. Just going through the option, we can identify that the Lagrangian is in polar coordinates. And here in the option C only, here is k by r square. Other three options k by r. Okay, we know that L is equal to T minus V. T means kinetic energy, that is half mv square. This is kinetic energy in polar coordinate, that is half m r dot square plus r square theta dot square. Here they given inverse square law. So V is equal to minus k by r. For inverse square law force, V is equal to minus k by r and F is equal to minus k by r square. K by r square. From this option itself, we can avoid the option C because here k by r square. Then Lagrangian is equal to T minus V, that is equal to half m r dot square plus r square theta dot square minus of minus k by r, that is half m r dot square plus r square theta dot square plus k by r. Gravitational force and Coulomb force are the examples of inverse square law force. When a particle moves under inverse square law of force, its orbit can be given by L by R is equal to 1 plus E cos theta minus theta dash, where E is the eccentricity. Where we can write L is equal to J square by M K and E is equal to root of 1 plus 2e j square by m k square. E is equal to 1, E is equal to 0, then it should be a parabola. If E is greater than 1 and E is greater than 0, it should be a hyperbola. E is less than 1, E is less than 1, then it should be an ellipse. These are the basic equations in inverse square law force. The relation between Lagrangian and Hamiltonian. Simply remember that H is equal to Px dot minus L. That is, this is the coordinate and this is the momentum and this is the Lagrangian. That is option B. Here is no dot here. So P q dot minus L. Consider small oscillations of a linear triatomic molecule. The resonant frequencies of vibrations are such that option A, one frequency is 0 and the remaining two are unequal. B, all are equal. C, two are zeros and one has non-zero value. D, one is 0 and the other two are equal. If we consider the triatomic molecule and small oscillations in triatomic molecule, linear triatomic molecule, the resonance frequencies can be written as omega 1 is equal to 0, omega 2 is equal to root of k by m, omega 3 is equal to root of k by m into 1 plus 2m by m. That is omega is equal to 0, omega 2 not equal to omega 3. That is the answer option 1. If the Hamiltonian of a system is invariant under the time translation. Option A, kinetic energy of the system is conserved. Linear momentum is conserved. Total energy of the system is conserved. Angular momentum is conserved. Total energy of the system is conserved. If the Lagrangian of the system is L is equal to half m r dot square plus r theta dot square plus z dot square, then r alone is a cyclic coordinate, z alone z and r, theta and z. What is cyclic coordinate? If a coordinate is absent in the Lagrangian equation, then dou L by dou qk is equal to 0. Then that coordinate is called cyclic coordinate. From this equation, it is clear that here r alone is a cyclic coordinate. It is not correct because r is present in the equation. Z alone is a cyclic coordinate. In the equation, z dot is there but z is not there. So option B is correct. Let's check the other two also. Z and r are cyclic coordinate. It is not correct because r is there. So z and r are cyclic coordinate is not correct. So option C is not correct. Then theta and z are cyclic coordinate. Theta dot is there but not theta. So option D, theta and z are cyclic coordinates. Hamilton's variational principle says that it is option C, delta integral T1 to T2 L dt is equal to 0. Exactly half of its proper length, the speed of the spaceship is. From the special theory of relativity, length contraction equation is equal to L is equal to L0 into root of 1 minus v square by c square. Here they given that the length of the spaceship is measured to be exactly half of its proper length. So we can write L0 by 2 is equal to, this is the length of the spaceship. Length of the spaceship. Length of the spaceship is exactly half of its proper length. Here proper length is L0. So L is equal to L0 by 2. So L0 into root of 1 minus v square by c square. So 1 by 2 is equal to root of 1 minus v square by c square. Squaring the LHS and RHS, we get 1 by 4 is equal to 1 minus v square by c square. We want to find out v. So v square by c square is equal to 1 minus 1 by 4. So v square is equal to c square into 1 minus 1 by 4. V square is equal to c square into 3 by 4 and v is equal to root 3 by 2c. Two electrons leave a radioactive sample in opposite directions, each having a speed of 0.67 c with respect to the sample. Then speed of one electron with respect to the other is. This is also from special theory of relativity. Speed of one electron with respect to other is written as u is equal to u dash plus v divided by 1 plus u dash v by c square. Here u is equal to v is equal to 0.67 c. So by substituting we get 0.67 c plus 0.67 c divided by 1 plus 0.67 square c square by c square. Then we get 6767. 60 plus 60 120. Then 7 plus 7 14. 120 plus 14 134. That is 1.34 c. 4c divided by here c square plus c square cut, and then 1 plus 0.67 the whole square. 0.67, that is less than 1. So the denominator should be 1 point something. So here 1 point something. So the answer should be less than 1. We can check the answer. So option A and option B is possible. The answer should be A.